Hello, this is Dan Thompson, and we're going to talk about different ways to secure your Spectrum Protect environment. It's important to note that these best practices or recommendations really have come from a variety of sources, including IBM personnel and customers. It's also very important to note that in many cases, you won't want to do each and every one of these. You're going to have to look and evaluate each of these and decide whether you've done them, you may have already accomplished them, or you need to do them. So if we look at this list, we're going to categorize this of protecting the hosts that Spectrum Protect server runs on, protecting the Spectrum Protect environment, particularly the servers, against ransomware and other types of malware, securing different parts of the infrastructure. If you look at a lot of TSM and Spectrum Protect environments today, although this is not universally true, there are some pretty laxly secured environments. There are things that people use these default passwords. They use the same account for everything, so there's no way to audit or track. A lot of times they'll turn off the firewall on the Spectrum Protect server. Client node passwords are either the same password everywhere or based upon something that they can infer by using that machine, like the machine name itself. Communication may not be encrypted. They may not do a lot of testing. Testing infrastructure, particularly one that matches the production infrastructure, can be very expensive and it may not be practical. You also find different versions of files, different versions of option sets. Users may not be receiving all the correct flashes from support when they need to know they need to apply an emergency fix, or the flashes may not be communicated effectively to say this is a critical highly pervasive problem that you really need to update. You also see that testing and recoveries are done by performing a recovery, so there may not be some kind of randomized testing, which is certainly some things that we do with third-party products, or people just schedule their own and say, okay, once a week I flip a coin, and okay, I'm going to do a file recovery, and then I flip it again, and okay, it's going to be a large recovery. Now let's just go out and do it. A lot of the problems also with DR testing is it actually stops the DR protection, and there's different ways to getting around that. To understand the Spectrum Protect security model, you need to know that each node is a construct within the TSM server. It's basically the container that owns data. You can also have other nodes that really don't direct data to, but they act on behalf of another node, and you can do that with a grant proxy node or the as node, from node, those kind of different parameters. But basically, within each node, unless you explicitly grant that access with a grant proxy node or with a set access command, no other node can access another's data. That's the basic security. Each administrator in each node has their own password unless you turn off password authentication, which honestly I've never seen. By default, an administrator has the lowest level of security or authority, and that is read-only. You used to call that analyst authority. Now it's just a default. And you have to explicitly grant higher levels of authority. We have rough role-based authority levels for admins, from systems, operators, policy administrators. And if you look in the manual, each command that you can issue will have a specific authority level required to run that command. Within this scope, you can also limit a user and say, okay, administrator, you have domain level access, but only to these domains. You have operator level access, but only to these storage pools, for example. We can also enforce complex password rules, having the password rules inherited from an external directory, an LDAP or Active Directory. Starting in 717, we also allow you to actually store the administrative and node definitions in an Active Directory. It doesn't support LDAP, just Active Directory in a specific container. So it's looking at that first requirement or set of recommendations, how to harden the Spectrum Protect server hosts. This is not going to be anything new. A lot of this is done by default by many organizations. We lock out the older services. We stop those services we don't need. We do use a firewall, and we put the rules in place so that the TSM or Spectrum Protect ports can pass through the firewall. We watch and keep the OS current We use strong rules for the OS accounts, including, preventing root level access directly, so that a user either has to log in it themselves and then SU over, or better, use sudo. You should always consider the backup engines to at least need to be as secure as the most secure data it protects. So if it's protecting a highly secure machine, that should inherit that level of security. Different OSs have different rule sets, and certainly some of these are defined by external organizations like the STIG standard that the US government maintains. If you're using the Spectrum Protect blueprint scripts to build a server, obviously modify the default passwords, and also you might want to consider expiring passwords as part of normal policy. You can use separate backup and admin ports. This gives you a little more flexibility on blocking administrative access for machines that you don't know an admin will be on. Now, this may have implications such as preventing certain kind of configuration scripts to run during client install. One of the things you can do is, if you've got a disaster recovery target, you might want to make sure that the OS accounts are different. So if a black hat gets access to that primary host, they're not going to be able to automatically get access to the DR host. If you've ever installed on Linux, you can see that secure Linux, SE Linux, you have to turn that off during the install. The manual does not specifically call out that you can turn it back on. And here are some examples of someone who's gone out there and looked at rules specifically for TSM running on SE Linux. You can even go hard. You can lock out secure shell on X Windows and only allow access directly. And this is not viable for network access, but if you have a data center where personnel are in the building, you can lock it out so only someone sitting at the console. So a black hat would have to not only know the passwords, but they'd have to find some way of getting in there and touching the machine. Let's talk a little bit about ransomware. Ransomware is becoming a big concern. Ransomware is malware that is targeted at an organization that is run like a business. It infects and encrypts data. So it'll infect a machine, and the first thing it does is go out there and try to encrypt data. Before it does that, it reaches back out to some central location on the internet and says, can I generate a key that can be used to decrypt this? Ransomware is the core of a business, directed by these criminal organizations. And so if it can't get a key to decrypt it, it won't do anything until it can get access. So it's important to understand the injection points and how they spread. An injection or infection point is typically people, or it may be a USB key thrown out into the parking lot where someone picks it up and then plugs it in to see if they can use it or figure out who the owner is. Anything like that, where if they can infect a workstation that doesn't really do anything to the workstation initially, it starts looking for those network shares. So it spreads through network shares and exports. The first thing to do with ransomware is understand how it works. And you can use antivirus software on systems and OS files. You probably don't do it on database or storage pools, but remember, current antivirus software, none of it detects most of the ransomware. Currently, Windows is the primary target of ransomware. You should not assume this is going to be true for very long. Certainly Mac, which is based on BSD, and certainly Unix. And remember, this is a business. This is not meant to annoy or impact the largest number of people. It's meant to generate a revenue stream. So they are going to expand this more and more. Obviously, you can limit user activity on Spectrum Protect server. Don't have people log in and read their email. Don't make it an infection point. You may not even want it to download software, even the TSM software directly. Just have it interact as little as possible. One of those ways you can look at this is limiting the cross-section or camouflage these TSM servers or Spectrum Protect servers so that they have a very, very low profile. They're not really visible in any way. If it's a Windows machine, don't make it part of the domain so it can be detected through domain. Don't broadcast Spectrum Protect servers to the directory. And there are a lot of ransomware specific hardening recommendations from security experts. you can probably go spend an entire week just going out there and reading one after the other. And a lot of it's just based upon limiting the cross-section, like a stealth machine, make it so it's not advertising itself and it's hidden as possible. One of the things that's becoming more popular is the concept of an air gap. Now, a true air gap machine is one that's not on the network, but this is a network-based backup engine, so what are you going to do? You can look at those things that in multiple layers, more and more air gappiness, if you will. So right now, the only targets for encryption are file systems and block devices. So physical tape or object storage, that's something that the hackers yet to target. Now, does that mean they're never going to target it? No, they're going to go for the backups at some point, but the ability to make it harder and harder. A next layer is, okay, what if I make a second copy of the physical tape and I put it somewhere else or eject it? You can start making it even harder. That's about as air gapped as you're going to get with this kind of infrastructure, is putting it on tape, making a second copy on tape, and ejecting that second copy. People have to be involved if they want to destroy or corrupt those tapes. And obviously, hopefully some common sense will be involved. Normally, I bring in a few older tapes. All of a sudden, it's asking for every single tape, including the ones I created yesterday, back in the environment. What's going on? If you have a disk-only solution, no tape, no object storage involved, and you're concerned, you may have to use maybe features of the controller itself so that you have a snapshot of the database. So even if those files do get corrupt, you have a copy that's not accessible. Once again, the hackers aren't figuring out how to get to the storage controller and destroy all snapshots. Is that going to be true forever? I don't assume anything is going to be true forever, but there are practical limits. They don't have infinite resources either for the development. Number 3 is secure the communications pathway. This is basically based upon SSL and firewalls. These are best practices. If you have a DMZ, obviously follow the rules so that Spectrum Protect server is isolated from the rest of the Protect infrastructure. If you want to, you can have it so the clients cannot initiate a session to Spectrum Protect. You can allow Spectrum Protect to initiate from the server side. That does require you to tell Spectrum Protect what the target address is. So let's look at internal to Spectrum Protect, what can we start doing? Certainly you can go through there and say, my administrative access. Don't use a single administrative account. Give every administrator their own account. That way you can audit. It also allows you to assign specific alerts to different people. Don't give administrative accounts that are used for day-to-day work more access than they need. This is not unique to Spectrum Protect. This is a somewhat common way of organizations where they have system or root level accounts that they only give out and they'll expire within a day, and then you have to call your manager or you have to call the security team, and oftentimes you have to have a change control or problem ticket necessary to even make the request. Sometimes that's even automated. If you have scripts or some kind of automation that do tasks, give them their own account. And also don't share just one account. If you've got one administrative account or one set of automation that runs on the Spectrum Protect server and does certain things, give that its own account. That way you can audit things more easily and track when there may be problems. Problems may not be malicious things. They may just be a script that's gone out of control. If you start getting commands issued and some kind of loot from scripts, it's very handy if you can at least identify what kind of admin it is. You can even lock that admin and not affecting the rest of your automation. If you have set up scripts that are at one time, then unlock the account, use it, and then lock it back up. One of the big challenges with automation is storing the scripts with a password within it. It's somewhat challenging. If you store a script and you've got a clear text password, assume that, I want a way to encrypt the password so it's not in clear text. The problem is if someone can see the script, even if you put it in some kind of command to get the password, decrypt the password and read it from a file, there's the command to do that. So it's really not that much more secure than a clear text password. You can do that. You can have a script that's, here, let me encrypt or obfuscate the password and store in a file, and have my automation scripts reverse that process. But you have to follow some common sense things. Put the scripts in a secure location. Put the password files in a secure location. The only real exception I know of that doesn't have this exposure is PowerShell on Windows. This has the ability with the convert to and convert from secure string commands to basically prompt someone for a password. It'll store it in memory in a secure fashion if you use the secure parameter, and then you use convert to secure string and you save that in a file. The reason this is more secure is only the user that saved it can reverse that. So if someone comes in with a different account, even a account with greater levels of authority, they won't have the same user key to use to decrypt that. So it's slightly more secure. You can also exploit an external directory from complex password rules, or as I mentioned with 717, even storing the accounts in Active Directory. If you use object storage or any other kind of storage that has a password securely stored within the TSM server, but don't then save it on a file on the TSM server or Spectrum Protect server that anyone can find. Stored elsewhere, stored in a secure location. A good practice as people move jobs or leave the company, make sure you decommission those accounts. So you can run a report and say, who is not logged in 90 days? Oh, that person moved jobs. Let's decommission or lock that account so that they can't get out of it or do anything. Or someone cannot work on their behalf. Like I said, it doesn't necessarily have to be them. Number 5, how do you secure those Spectrum Protect clients? One of the worst habits we have is people using a well-known password. So if they can get access to the console and using password access generate, they can already get to the data. That's a given. So if you don't want that to happen, you can't use scheduling and CAD daemons. So if you want to use password access generate but not have people be able to log in, then go ahead and secure the location so a user logging in can't even get to the executable. Bottom line is, use a complex password. A lot of times it's just random because after it expires, it's going to be random anyway. So the worst thing I've seen people do is use a well-known password and then turn off password expiration for those nodes so it never randomizes. So anyone who knows the trick to knowing the password, they can get access to anything. You can lock out the executable, the password file, and things like that, including the registry key. Audit for password exceptions. Watch out for when someone is logged in and is just trying to figure out the password. You can have people use the web client, including launching it direct from the OC, and then they can need to log in with themselves. This is the key to the random password thing, is they either need to go to the console or use the web client, and when the web client, if they don't know the node's password, they'll have to log in as themselves. You can use the audit logging parameter on the client, and this will give you much more detailed about exactly which file was backed up or restored. You can also use the report retrieve parameter on the server, and this puts on the server activity log, when data is being retrieved. So you can see what node logged in is what user has restored a file. There's an example there. One of the things you want to eliminate is people having to go out to the console if possible. So we have a client management service, so you can view the client logs within the operations center, and you can register different logs for the client management service, so you can add the instrumentation trace and the audit logging into the logs that the operations center shows. And one of the big things is staying on top of warnings and error messages generated from the client stored on the server. One of the biggest challenges we have is people say, okay, these files I never back up, or they may detect it and then go away and then it gets a warning, and they just kind of get used to those warnings. The problem is those warning storms hide critical things. So you do want to, whenever you get more messages or warnings and you want of a certain type, try to keep on top of that. Number 6, make sure that you get all the supporting alerting tools. Get the alert flashes from support with IBM for TSM and Spectrum Protect. Make sure you've identified all the things you should get alerts for, including Spectrum Protect, including the operating system, anything that's related. Critical fixes need to be tested and applied as quickly as possible. And make sure if you're not responsible for the OS, that the people are, they do get those flashes and the hardware flashes. Adopt the alerting model so that you can have a good change control and problem management process where you assign out a problem and they have to be closed. You want to kind of adopt these different kinds of like ITIL practices, or for example, where I have problem management that's being followed in a specific way, or change control. And certainly one of the things that I've seen is people will have a problem and they'll start working on it themselves because it's more convenient. They don't really want to open a problem ticket. They don't want to have to answer a bunch of questions. I will tell you honestly, when I was a customer and then called support, I just had a default rule. I had files that were up to date that talked about versions and hardware and everything in the world. And that way, I don't have to worry about what question they're asked, because I'm going to give them this set of information and the logs before I even get any response from them. It's a way of short-circuiting the back and forth, and a lot of times it's better from your side because then you've got up-to-date documentation. And that way, if you just keep it up to date and you can just fire it off whenever there's a question, and also get used to those things that people are going to ask you. Show me the activity log on the server and the client for the time frame. Just kind of anticipate them. Another thing, and this goes along with these standard ITIL or PCI kind of processes, is have strong currency and testing policies. If a release is gone, I make sure I apply it within 18 months, and I do have relatively strict testing of different types, whether it's just, will it run on my OS without blowing up? Will it interact with the software? Do I test each client type, at least the ability to log in and do one backup? Have some sort of reasonable testing policy. Even if you cannot build an exact infrastructure because of cost, you can build a VM or download our trial VM and just say, okay, I'm going to go out there and make sure that at least my clients will back up to that. So this is really nothing other than just following these good, strong policies that are recommended. Even if you don't go to the letter, these things can be quite complex. But just in general, have a good faith attempt of following the concepts as much as you can in a practical manner. Validate your data protection service. This is basic with any kind of service. How do I validate it? Most of the validation is done by doing the service, restoring it. It's very challenging in this business. You get some monitor and manage backups each day, and the restores kind of take care of themselves, where when we perform a certain number of restores, and if they're working, we don't assume there's a problem. There's another way of managing the service. You can do this fire drills once a week, and say every Wednesday we run a fire drill. Someone flips a coin and it decides what kind of data. We flip another coin in which server. We flip another coin and what is the scope of the restorer. And this allows you to have just some randomized testing. There's also third-party products from Christie and from TSM Works that are specifically for these purposes. It's important, if you have critical and non-critical data or machines, have different classes of service and monitor appropriately. If you have a platinum level, make sure the backups were within a certain level of performance. Make sure they're current. And having a requirements-based way of managing your service can make your life a lot easier. You can spend a lot of time trying to resolve non-critical issues if a more critical issue is sitting there. If you have a disaster recovery testing, try to configure it so that the DR replication doesn't have to stop during the testing. Spectrum Protect node replication, for example, can allow you to recover data while still doing replication on an ongoing basis. Now, if you have to do backups during the DR, you have to take extra steps because you can't be updating it from a node from backups and replication at the same time. So you may have to set a node to not being the replica target and then let TSM reseed another copy so you can back up to that copy of the node, do whatever you want, and when you're done, just delete it, and the node replication would have reestablished that secondary node. So you can kind of doing that by turning off replication to a node and then renaming it and then making sure replication creates another copy of the node. It's a little extra work, but it allows you to maintain your quality of service. And obviously, monitor the ingest workload, monitor the servers themselves to make sure the CPU, memory, RAM, etc. is all working within your intended specifications for a given engine. Make your TSM server or your Spectrum Protect environment as easy to manage as possible. Try to standardize, use a cookie cutter methodology, or I call it the Lego methodology. Spectrum Protect blueprints certainly assist with this quite a bit. Standardize your naming convention for everything so it's easy. The blueprints have examples of these, and you can even include the retention and versions and different names of different management classes. If you have managed objects that you want to be identical across Spectrum Protect servers, you can use our enterprise management, where you put those objects in a managed profile and you have the other servers subscribe. Monitor the workload for a given instance. We've talked about that. There's a certain amount of free horsepower, free space, and things like that for ad hoc spikes, for large restores. The problem with running an engine at its max capability is that it ignores the fact that this service has a lot of ad hoc spikes, including those restores that you can do very rarely, but you've got to design it into it to be able to restore a certain part of your infrastructure, ideally without having to stop the data protection service itself. You can also say, if you want to go out there and look at a good version, currency rule, but you want to be able to take advantage of IBM's agile development with Spectrum Protect, you may have the Operations Center and Hub server running on a different instance. This allows you to maybe apply fixes that have to do with the OC, the interface itself, more aggressively than you do those on the backup engines. Number 10, how to make the clients easy to manage. We talked about this, having currency rules, use server-side clops rather than putting a lot of stuff in the client options that are on the machines. Allow clops to override the client options so people can go out there. You're certain that there's not being overridden. Exploit the client management service. You can have the client instrumentation trace and auto logging in the client management service set of logs. I'm a big fan of using an auto-configuring installation package where it will register the node, where it will define things. That way you can ensure consistency, not a manual process. Once again, use an auto-configuration so it's highly automated, and this will allow you to increase the consistency. I wanted to talk about one final topic and then we'll be done. It's the topic of data sanitization or recovery from a data spill. A data spill is when critical information that is secret or confidential has been stored in a location that does not necessarily have that level of protection. So if someone says, oh, I have a file with all my clients' names and social security number and addresses, and I saved it on the public file server, I immediately the next day said, oh, I cannot do that. That was irresponsible. I delete it. The problem is, even after I've cleaned up the spill, it may be in the backups. So how do you go out there and clean up the backups? It all depends on what kind of storage pool you have. The first thing you do is find out where in your storage pool, whether it's in a volume or a container, that spilled data is stored. If it's a deduplicated container pool, it's going to be a relatively complex list because you may have bits and pieces all over these different containers, and other data may reference those chunks, those extents. So you have to first figure out which containers contain the spill, which volumes contain the spill. Once you know that list of what you have to clean up, set the reuse delay on the storage pool to prevent those volumes from being deleted until you're ready. Then go out to the client and clean up the data. Issue a delete from whatever client type so that data is gone. After that happened, run expiration. You can just run it for that node. Now go out and on those volumes or containers, issue a move container and move volume. This moves the good data elsewhere. So anything that is needed for other data for other recoveries and is not part of the spill exclusively is moved. Once you've done that, you can destroy the container volume. If it's on a file or a file system, you can go out there and issue an OS command that's for Unix. It's the shred command. On Windows, it's sdelete. And certainly if it's a tape, you can just take it and smash it with a hammer or just degauss it, whatever your policy is. Now, we do have a little bit of good news. With container pools on the cloud, you have optionally the ability to encrypt those extents. Once you've cleaned out the extent and issued the move container and it moves it, that extent will go away. And the encryption key for the extent will go away. The NIST calls this cryptographic erase. So you have to look at your organization and say, is that acceptable, rather than actually having to shred it. We're looking very hard about how to help people really start doing this, because this can be quite critical, because unfortunately we see mistakes happen commonly where this high secure data is moved to somewhere that's less secure, detected, removed, but now we've got to figure out how to clean the backups and archives out. Well, that completes the presentation. I hope it was helpful. Certainly, if you think of anything that we are just missing, let us know. My email, danthomp@us.ibm.com. Thank you very much.